This clip is about sketching the graphs of sine, cosine and tangent. We already know from basic trigonometry that sine x is given by the opposite over the hypotenuse. So in this triangle here, that will be this height, which is opposite the angle, divided by this, which is the hypotenuse. You'll notice that I've drawn this circle with a radius of 1, so that when I do my opposite divided by my hypotenuse, I've actually got O divided by 1, and anything divided by 1 is just the number itself. So for this particular triangle here, sine x will just be the length of the opposite side. In a similar way, from basic trigonometry, we know that cos x is A, that's this side here, divided by the hypotenuse h. Again, remember that's 1. So, for this particular triangle, A divided by h is just going to be A, the length of this side here. So to help us understand how to draw the graphs of sine and cosine, we're going to be using the idea of drawing triangles within this circle with a radius of 1, which we call the unit circle. When creating my angles, I always start from this line here and work in an anti-clockwise direction. So if I create an angle here, like this, and I call that angle x, then sin x is equal to this distance here. And in the same way, cos x is equal to this distance here. So we have sin x and cos x. To draw the graphs of sin x and cos x, we're going to look at what happens to these distances as we increase x from 0 degrees through to 360 degrees within this circle. So here's my circle, and at the moment my angle of x is 0 degrees. So the height here, which is sin x, is also 0, and you can see that here. Now let's increase that angle. I've now increased x to 30 degrees, and you can see that sin x is this height here, which is actually 0.5, and I've plotted that on the graph at 30 degrees. Now x has increased to 60 degrees. In the same way, we get the height here, which is actually 0.866, and we plot it on the graph at 60 degrees. When x is 90, we can see that sin x is this distance here, which reaches the edge of the circle. Remember, the circle's got a radius of 1, so that makes it 1. And again, we plot this on the graph. Now, what's going to happen to the height as I take the angle past 90, let's say into 120, and how will this affect the graph? So if we set that angle to 120, we can see that the height actually goes down to this height here. So the maximum height it will ever be is the radius of the circle 1. So this here is the maximum of the graph. Now this height here, you will actually notice, is the same as this height here. This is what we had for 60. So the value of sine x for 120 is the same as it is for 60. And it gives us symmetry in our graph. When we go to 150 degrees, the height gets even smaller again. It's the same as it is over here, which was the value we had for 30, so the symmetry continues. And when we get to 180 degrees, we're completely flat again, so there's no height and we're on 0. Now, if we look at our unit circle, we know that the maximum value at the top here is 1. What's the minimum value at the bottom here? Well, that will be -1 because it's below the x-axis. So what do you think is going to happen when we take our angle past 180 degrees? What happens is that we start to get negative values for sine x, and we plot them like this. We can continue round the circle. We get to -1 here. Remember, that's the minimum value of sine x, and that happens at 270 degrees. And then we can carry on around the circle, bringing ourselves back to another value of 0 at 360 degrees. If we now join these dots together with a smooth curve, we'll get all the intermediary values of sine x as well. I'm also going to put on my y-axis. So this is a sketch of the graph of y equals sine x, and you need to know the shape of this and some of the important values off by heart. The first three important values are these ones, where sine x is 0, and that's here, here, and here. There are two other important values that provide the maximum and the minimum of the graph. Sine 90 is 1, and sine 270 is -1. Again, make sure that you know the shape of this graph and the important values off by heart. Now, we've just looked at the height, which gives us sine x. If we were to do exactly the same thing for cos x, we would be looking at this distance here. The resulting graph will look like this. Again, notice that the maximum value is 1 and the minimum value is -1. You need to know what this graph looks like off by heart. Remembering these important points will help you to do that. Now, one of the main problems is remembering which graph is actually which. I'm now going to show you a nice way that one of my students actually came up with that really helped her remember which one was which. She remembered that if she wanted to draw y equals cos x, cos begins with a c. So the graph, if you tilt your head onto the side, is kind of C-shaped. Once you've got the basic C shape, all you need to do is remember that that's 1 and that's -1. This here will be 360, making the halfway point 180, this 90, and this 270. So we have zeros here and here, 1 here and here, and -1 here. She also remembered that if she wanted to draw y equals sin x, that sin begins with an S. So again, if you tilt your head, the graph is kind of S-shaped. Admittedly, it's backwards, but it's certainly more of an S than this one is. The only thing left is to remember that this is 1 and this is -1. This must be 360, making the middle 180. This point here where it hits 1 is 90, and this point here where it hits -1 is 270. You need to be able to reproduce sketches like these in an exam situation. This is a typical exam question, and I'm asked to find the value of x for which sine x is 0.9397. So I know that sine x is 0.9397. Now this question would appear on a calculator paper, so to find the value of x, I can do inverse sine 0.9397 using my calculator. Remember, to do this, you press Shift sign and then type in the number. I get 70 degrees to the nearest degree. So this is my value for x. But if I look in the question, it says find the values and give your answers. So that's a pretty clear indication that I need more than one value. I've got to find all the values that this occurs for between 0 and 360 degrees. So to do this, I'm going to draw a sketch of sine x to help me. I can now use my sketch to help me find the other values of x. I already know that 70 degrees is one value, and that's about here, and it's giving me the sine, which is 0.9397. Now I can see from the symmetry of the graph that if I carry on, I'll get another value here for the same value of sin. Now remember, this was 70 degrees, so it's 20 degrees to the left of 90. So if I go 20 degrees to the right of 90, that's 110 degrees. So one of my values is 70 degrees, and another value is 110 degrees. If I just check, I can see that nowhere else on the graph will give me this same value, so these are my two answers. Just out of interest, another way of getting the value of 110 is to realise that our one value is here at 70. So using the symmetry of the graph, we can take that 70 away from 180 to give us 110. Here's one of those for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another one for you to try. Be careful because this time it's cos x, not sin x. Press pause and have a go. When you're ready, press play. Using your calculator, you should have got an answer of 132. To get the other answer, you need to use your sketch. We can see that 132 is here. The other value will be here. So to find this value, I'm going to use the symmetry of the curve. It's symmetrical about the 180 degrees. So from here to 132 is a gap of 132. So to get this value, I can subtract 132 from 360, and I get 228 degrees. So my other answer is 228 degrees. So the answers you should have got are 132 degrees and 228 degrees. Now this question would appear on a non-calculator paper. I want to find the exact value of cos 330 without using a calculator. Now to start with, I don't have a clue what this is, so I'm going to draw a sketch of the graph of cos. Now 330 is here, so the value of cos 330 is this. And I can see that it's the same as the value of cos whatever this is. Now this is 30 degrees away from the 360, so this must be 30 degrees away from 0. So the value of cos 330 is the same as the value of cos 30. So if we know the value of cos 30, then that will be the same as the value of cos 330, which is what we're looking for. Some of you might have memorised this and be able to just write it down straight away. Some of you might prefer to use the little trick that we looked at in grade 5. So remember, to find cos 30, we want the number of fingers on the right, which is 3. We want the square root of that, so that's root 3, and divide by 2, so that's divided by 2. So the value of cos 30 is root 3 over 2, and this is also the value of cos 330. So this is the answer to the question. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers.